last example for this lesson is about finding a percent of a number, and they're going to use a story problem to help us to see how that works. The example says, find the weight of the pygmy hippo described on page 340. So that's the example we reread at the very beginning of this lesson. And we're finding 10.5 or 10.5% of 5,600. That's because the pygmy hippo is 10.5% of the weight of a regular hippo, and a regular hippo was 5,600 pounds. So we're going to find 10.5% of that number. So they're thinking about how 10.5% of 5,600 is the same as 0.105. So they're taking the percent and changing it into its decimal form by moving the decimal point to the left twice. So 10.5% is 0.105, 105 thousandths. Of is times, and of course we have that 5,600. They've done the multiplication already, so they did this multiplication somehow, either on a calculator or on paper, and it comes out to exactly 588. Now, how did they do that? If you're not allowed to use a calculator, you can either use traditional multiplication or you can use lattice. For traditional, you might set it up like this, 5,600 times 105. I guess I wouldn't worry about the decimal point until the end, and I would do my multiplication. 25, 28, let's see, 1 times 0, 1 times 0, 1 times 6, 1 times 5. So there's my finished multiplication, and in my original problem there were 3 decimal places, so I'm going to move in 3 decimal places and place my decimal point. So there's that 588 that they got. You could do the same using lattice if you wanted to. So the answer to the question is the adult pygmy hippo weighs about 588 pounds. You can check for reasonableness. You can use estimation to check the reasonableness of the result, because 10% of 5,600 is 560. The answer is reasonable. Now, where did that 10% come from? Whoops, excuse me for just a minute. I'm going to, there we go. 10% is close to what we're looking for. We're looking for 10.5%. And 10% is just easier to work with. 10% means 1/10. So 10% or 1/10 of 5,600. You could just find that by dividing by 10, which essentially moves the decimal point to the left once or drops a 0. So you can tell that 10% of 5,600 is 560. And 560 is fairly close to the answer of 588. It's smaller because 10% is smaller than what we're actually looking for. We're looking for 10.5%. But it just makes our answer look reasonable. So here's example 4, finding a percent of a number, same type of problem, but a different situation. Day of dread. In a survey of 1,300 adults, 18% said the day that they dread the most is Monday. The question we're supposed to answer is how many adults chose Monday? Well, 18% of the people surveyed said Monday, so we're looking for 18% of all the people, which was 1,300. 18% of 1,300 can be translated into 1,800ths by moving the decimal point to the left twice, times 1,300. And now we have to do that multiplication. That can be done on a calculator at times. If I'm asked not to use a calculator, I'm going to try to figure out how to multiply this without a calculator. I'm going to do just 18 times 1,300 and worry about the decimal point at the end. And I think I'm going to do 13 times 18 first. Maybe I'll use lattice here. 13 times 18 and worry about the zeros afterwards, because this will be simpler. So 1 times 3, 1 times 1, 3 times 8 is 24, and 8 times 1 is 8. So I'm ending up with 4, 10 and 3 is 13, and a 2. So I'm getting 234 as my answer to 13 times 18, but it was really 1300, so I've got to add 2 zeros on the end. 234 with 2 zeros. So the answer to 18, just 18 times 1300 would be 23,400. Now I'm going to place my decimal point. In the original problem, there were 2 decimal places. So I've got to back up 2 and put the decimal point in there. So I end up with 234 as my answer to that multiplication, which means the answer to the question is the number of adults that chose Monday is 234, which also means that 234 is 18% of 1,300. All right, so we have, at this point, if you're feeling comfortable and you understand what's going on, you could go ahead and try your checkpoint questions. If you're feeling a little uncertain yet, you certainly could stay with me and do a few examples. Let's start with number 13. So these are extra examples for those who would like more instruction. 20% of 85 would mean 20% as a decimal is 20 hundredths or 2 tenths. So I can do 2 tenths of is times 85. 2 tenths of 85. So I'm going to just do 2 times 85 first and then worry about the decimal placement afterwards. 2 85s stuck together. Let's see, 80 and 80 is 160. 5 and 5 is 10. So that's 170. But there's a decimal one decimal place in my original problem, so I'm going to have to back up 1. The answer to that multiplication is 17. So going back to my original question, 20% of 85 is 17. Let's try another one, number 14. 3.8% of 45. Well, I'm going to have to translate 3.8% into its decimal form. Moving the decimal point to the left twice, I'm getting 38 thousandths is 3.8%. And 3.8% of 45 would involve this multiplication. Now, because I'm trying not to use a calculator, I'm just going to multiply 38 times 45 first. I'm going to use traditional here. 5 times 8 is 40. 15 and 4 is 19. Oops, excuse me, 32. 12 plus 3 is 15. So 0, 7. So we're getting 1,710 as the answer to 38 times 45. But now we've got to consider the fact that there were 3 decimal places in the original problem. So I'm going to back up 1, 2, 3, and it looks like 3.8% of 45 is 1 71/100. Now 3.8% is a pretty small percent. So it makes sense that we should end up with a pretty small part of 45 for our final answer. Moving on to number 15. We're looking for 125% of 64 here. 125% is the decimal 1 25/100. And 125% of 64 would mean multiply that by 64. So I'm going to multiply just 125 by 64. This time I'm going to use lattice. 5 times 6 is 30. 6 times 2 is 12. 6 times 1 is 6. 5 times 4 is 20. 2 times 4 is 8, and 4 times 1 is 4. Adding on my diagonals, let's see. 5 and 1 is 6, plus 4 is 10. 6 and 2 is 8. So it looks like I'm getting 8,000. That would be the answer to 125 times 64. But there were 2 decimal places in the original problem. So I'm going to back up 2 and put my decimal point in here, making the answer to the decimal multiplication 80. So back up here, 125% of 64 is 80. Now does that make sense? 125% is more than 100%. So I'm looking for more than 100% of 64. So it makes sense that there's a number, I ended up with a number that's bigger than 64. All right, last one, number 16. 0.5 or 1/2 of 1% of 600. This percent is equivalent to the decimal 5 thousandths. So I'm going to do 5 thousandths of 600, or 5/10 of a percent of 600. All right, so now I'm ready to multiply. I'm just going to do 5 times 600, which I know would be 3,000, or 3,000. I'm going to go back up here and think my original problem had 3 decimal places. So 1, 2, 3, and there it is. 1/2 of 1% of 600 is 3. This is a tiny percent, so it makes sense I should end up with a number that's a small, small portion of 600. Last practice problem here, number 17. In a survey of 1,100 adults, 2% chose cooking as their favorite leisure activity. The question is, how many adults chose cooking? So I'm looking for 2% of all the people who were surveyed, and that was 1,100 people. Now 2% can be written as 200ths. So I'm going to multiply 200ths of 1,100, or times 1,100. Simplifying things a little bit, I'm going to just do 2 times 1,100, which would be 2,200. And now going back to the original problem, there were 2 decimal places. So 1, 2, put your decimal point in there, and you end up with 22. So 2% of 1,100 is 22. And what does that mean? 22 adults chose cooking as their favorite leisure time activity. Now that ends our practice problems. So now you can go ahead and try your checkpoints 13 through 15 in your note-taking guide on your own. We will talk about them in class.